Hi, I'm happy to be able to present Lumito for you all. My name is Stefan Nilsson and I'm the CEO of the company since 2 years ago, when the company started a new strategy for building products out of its IPR. So what are we doing? We are actually changing the way you can do tissue diagnostics. Today you can see the image on the right side of the slide here. That is the normal way of how tissue is presented, tissue information is presented to pathologists. It's an H&E staining, hematoxylin eosin staining. And as you can see, the information, there's a lot of background information, and when you're looking for specific tissue, malign tissue, it can be difficult to find that with all those information. And that's the reason for when they made the studies of this, that it's you can have inter-observer agreement for of 70%, 70-75% when doing diagnosis of tissue samples. And of course, it's not the very obvious ones where there's a lot of expression of for instance, cancer, or the very where there's very benign samples. But in the middle, it's even less than this 70-75% when it's atypic tissue or pre stages of cancer, for instance. So that's what we are aiming for, to improve that and to make high-end the accuracy. A brief history of the company. The company was founded by researchers in Lund University in the early 2000, and by researchers led by Professor Stefan and that's the Institution of Atomic Physics in Lund. Based on the research, they started the company in 2010. And as I mentioned, the strategy was changed in 2017, where at the same time I entered, and our CTO, Anders Sjögren, with the goal to do products, develop products out of the IPR. The patents here is I will come back to that, but that is basically imaging based on a specific form of nanoparticles called UCNPs, up-converting nanoparticles. We started in 2017 by doing a new product plan, strategy, and funded that. And the proof of concept started in early 2018. And now we are in the middle of the development phase of the first products, which we are aiming for launching in the first quarter of next year. So as you can see, we are moving quite fast within this industry with the diagnostics instrument. This is quite fast. So our focus, we have focused on tissue diagnostics and medical medtech applications, where tissue diagnostics is the first form. As I said, we were basing all this development on the company's IPR. We have patents in the main markets approved, and also patent applications for specific applications, such as immunohistochemistry. And of course, we are a part and wants to drive the track towards digital pathology. Today, digitalization within pathology is not very high. And there are certain challenges, which I will come back to, that we also address. How could we do this in such a fast manner, since we started with mainly the patents and the research in 2017? We have made a setup where we outsource all development to our partner, TTP, the Technology Partnership in Cambridge, UK. So they are doing all the development work on our requests. And that made it possible for us to start directly as soon as we got funded and do the proof of concept phase, and also to scale in a way that is not possible otherwise. If we were supposed to build our own development department, we would not be out of the proof of concept phase today. So that has been a real success factor for us. So we are keeping the core competencies in the company, but we are doing all the development work with our partner. So what is the reason for doing the tissue diagnostics? When we looked at this, we saw that the market is increasing with 10% per year. And the reason for that is that the aging of the population, basically. The demography is people are the average living years are increasing, and thereby also the sickness level. So that's one. The second one is that treatments are now more specialized and individualized. So to be able to do very precise treatments, you need very precise information about the indications, and the diagnosis must be very precise, and therefore more samples and diagnostics are made. So and the third one is that in the third world, developing countries, the living standards is increasing, and therefore people can afford to be diagnosed and have treatments. One of the very important reasons for this is also that pathologists is a limited resource. So the ability to diagnose all these tissue samples is not increasing along with the demand. So there are lots of drivers that for a method and the workflow that could increase the throughput in the system. So our goal, we are doing this in two steps basically. The first step is to provide a system and kits to improve accuracy, so that the pathologists themselves can have better information and do more accurate diagnosis, and also be able to multiplex within the same samples, the same tissue sample for different indications, and also multiplex with the hematoxylin stainings, as you see in the first image, and by that we can reach the market very fast and can get our technology out to the labs and to the pathologists. The second step is, with our technology we are able to do quantification, since we can measure the light from the nanoparticles, and thereby do quantification of the expression of, for instance, the cancer cells that is in the sample. That is very difficult or impossible to do with the current staining methods available today. And that is also important for the pathologist to when they are doing diagnosis. So what is it we are doing that is specific? We have these nanoparticles, which is the big let's see here, there we are. And this is a very general description of this. We put, for instance, biotechnological antibodies on it. Those antibodies stick to the antigen we are looking for in the tissue sample. And therefore we have a nanoparticles stuck to exactly what we are looking for. We stain all the sample with this, and then we excite with laser light on the sample. And this specificity of the these nanoparticles are that if you excite them with a certain light, they will send out light with a shorter wavelength. Everything else in the sample, when illuminated, will be send out light with longer wavelengths, and therefore we can really see the difference between our particles and the rest in the. So all the background is basically removed. So you can have the analogy with the needle in the haystack, that we remove the haystack and you see only the needle in the sample. So this is the kind of images we get. So here you can see this is tissue from colon that we have stained with phosphatidylkeratin, and you can see that you don't see the background, you just see the structures of the cells that we are looking for. So this is so if there were no such cells that we were looking for, then these images would be completely black. So this is just to compare, and this is very obvious. We have done hematoxylin staining together with our particles, and you can see that the background is removed, but this is also to show that we have specific staining around the membrane here of the epithelial cells. So this is was done in the proof of concept to show that we have specific staining with our method. These are cultured cell lines for breast cancer, and where we have stained with our particles. And as you can see, we have very high resolution, and you can see very well the structures of the cells. And it's also co-stained with so-called DAPI, the blue things, who stains the nucleus of those cells. And these are for another indication of breast cancer, HER2, which is Herceptin marker, and also you can see the same thing here. So it's very specific and very clear what you have. I was told a little bit about the tissue diagnostics market, and it's growing by 10%, as I said. The two big markets are North America and Europe. Europe about 30%, and North America about 40% of the total market. And we are going with a strategy for Europe first, since we will be able to launch our products very quickly on that market, and then North America as the second market. Roadmap, I have been into that a little bit. The roadmap, we are in the middle of the development phase, and we are optimizing both the instruments and the reagent kit. Our product is of course the instrument where you can view and make images out of the tissue samples, and also staining kit where you stain the tissue sample with our particles. So that is so we will have both an instrument and recurrent sales of reagent kits. That's the business model, and we will go over to the third phase in this autumn, and to be able to CE mark and set up production and transfer to production and stuff. And we have the aim of launching the first products in first quarter of next year, the Q1. So this is just some pictures of, this is the alpha prototype we have built, and this is an indication of how it will can look like in Q1 next year. So we are doing the alpha prototype ready now, and the beta will be in end of Q3, and then we are going for approvals and production. This is the only Swedish slide here. We are in the midst of signing period for units that will cover to develop the products and over the product launch. So with the end of signing period in the May 31st. Yeah, I think that was about it. Thank you.
Thank you very much, Stefan. So this sounds like a sort of a revolutionary technology.
Yes, there are lots of where you try to use those H&E stainings and, for instance, do artificial intelligence applications or machine learning approaches to increase the accuracy of the diagnosis. We are doing the opposite. We are trying to highlight what we are looking for and reduce the background, and then to do automatic analysis in the step 2, as I indicated earlier. So it is our goal is to really revolutionize pathology.
And in which area specifically, isn't as far as indications go or different sectors, where do you see the biggest potential?
It's to diagnose cancers.
Yeah.
That's different kind of cancers. So we are using markers that we are not developing the markers, the antibodies. We are using commercially available antibodies that is already used in the pathology labs, but we are like sticking the USMP, the nanoparticle to them, and by that we can reduce all the background and make it possible to improve accuracy.
And going forward, presuming that everything goes well with the development and so on, you have a market launch plan, of course. When introducing a new technology, like especially if it's revolutionary, there are always challenges. What do you see as the main challenges for Lumito in that aspect?
Of course, the conservatism. Of course. It could also be that when coming with a new technology, you have to prove yourself, and that will take some time. So our approach will be to find reference laboratories where we can work together with as the first customers, and to get quick results out of that we can use for information to inform the society, pathology society about our products.
And are you, as of now, in discussions with any specific clinic?
Yes, we are in discussions with several parties for that. Yeah. So everyone, of course, want to see it. So we now when we have the alpha prototype, we can do some presentations and demonstrations as well.
Okay. What about the competition? I mean, of course, the standard technology used today is the main competitor, you could say. Yes, but are there any competitors within the same field?
No, and we haven't found any that has the same approach as we do. Of course, there's a lot of research around those particles, for instance, but our IPR is mainly covering this. As I said, artificial intelligence applications. That's the main competitor, I would say.
Okay. We'll see if are there any questions from the audience today. Yes.
Would this procedure be significantly more expensive than the present-day technology?
We are optimizing at this moment, and our our goal is to come down so that it will not be significant. And indications we have that that is possible, so that we can come in within a range that is we will be slightly more expensive. But in the other hand, we can do co-staining in the same tissue samples, which will reduce the number of samples. So you could do a good calculation on that.
Of course, cost efficiency is an increasingly subject that's being discussed a lot within the healthcare right now. Yes. And who would you say are key to convince here in order for you to get a really good market uptake?
That's it's the head of the pathology department, because if you can't go through there, the procurement will not buy from the hospitals, for instance.
Yeah.
So that is the key person or key persons.
Yeah. We have another question.
What is a future business plan? How to sell this? Are you going to sell the product? Are you going to sell the license for the software? Or are you going to sell based on the numbers of they're doing or whatever?
As a first, we will sell ourselves first for the reference customers and the first early adopters of this technology, and then we'll go for a distributor strategy. And we will. We have adopted our system, so it's this. You don't change the workflow within the labs, for instance. So the labs are used to buy instruments and buy reagent kits, and we will adjust to that at least as a start.
Well, just another question.
More of a comment. Where I see the future is the automatization,
yes.
Because everyone knows there is a severe lack of pathologists. So you must get quicker through flow of material.
Yes, and we see that too. So that's as I showed you, the step 2. It's quantification and automation. And based on our technology, the images are with higher contrast and no background will be easier to do a automated system for that than the ones you saw, the hematoxylin eosin with a lot of background. So of course we are aiming for automation. But as a first step, we let the pathologist have this as a additional tool for when they're doing their diagnosis. That makes it easy for us to certify the product and get it out on the market. And in the meantime, we will develop the automation.